Hey, it's Joy. Today I'll be talking about the solubility product constant. The solubility product constant is represented by KSP, and KSP is the equilibrium constant for a solid substance dissolving in an aqueous solution. The more soluble the substance, the higher the KSP value. When comparing KSP value and Q, if Q is greater than KSP, the solution is supersaturated and precipitation will occur, similar to what you see in the picture. Reversal of the reaction will have to occur for it to reach equilibrium. If Q is less than KSP, the solution is unsaturated and the reaction proceeds forward. More solid will be able to dissolve. If Q equals KSP, the solution is saturated and no more solid will dissolve or precipitate. And here is a particulate diagram of the unsaturated solutions versus saturated solutions. This diagram shows that basically whether Q is greater than KSP or if Q is less than KSP, the goal of the reaction is to reach equilibrium where Q equals KSP. And this is explained by Le Chatelier's principle. To expand on that principle, some variations in KSP can occur due to the common ion effect, the diverse ion effect, and temperature changes. The common ion effect is when the solubility of an ionic compound decreases when a salt containing an ion already present in the mixture is added. The diverse ion effect is basically the opposite, so when an uncommon ion is added to the mixture, it will increase the solubility of the substance, and temperature change affects KSP values because in endothermic reactions, temperature increase will increase the solubility of the substance, which will increase the KSP value, and in exothermic reactions, temperature increase will decrease the solubility and decrease the KSP value. So now it's time to do an example, and we're going to be calculating KSP using concentration. So, in a saturated solution of silver phosphate at 25 degrees Celsius, the concentration of the silver ion is 4.3 times 10 to the negative fifth molar. And using the equilibrium constant expression given here, we're going to calculate the value of the KSP for the silver phosphate. And it's important to notice that in the KSP expression, we won't include any pure solids or liquids. So first, it's important to write out the BCE because you can see the ratios that will be important for the rest of the problem. And using that BCE, we can see that the silver ion and the phosphate are in a 3:1 ratio in the products. So because we're given the silver ion concentration and it's a 3:1 ratio based on the BCE, we can divide that concentration by 3 to get the phosphate ion concentration, which will be 1.43 times 10 to the negative fifth molar. And then we can use the expression to input the values that we found and were also given. And from this, we'll see that the KSP will equal 1.14 times 10 to the negative 18th. Also, it's important to notice that the KSP values don't include any units. And that is the end of the presentation.